Well, good afternoon, everyone. Welcome back from the break. Hope everybody got a chance to get a little bit of a clear head before we go into the last panel of the day. I'm putting up the number here for the Slido so you can get ready to ask your questions for the panelists for our last panel of the day. So I am David Erne. I am Deputy Director in our Energy Assessments Division within the California Energy Commission, focused on resource planning, reliability, and emergency response. This panel is focused on ideas from outside of California. I find this panel a little bit unique. For all of the workshops I've ever been involved in the state, I moved here about 7 years ago, because it's rare that you come to a workshop and California admits there might be better ideas somewhere outside of California. So we're trying to bring these ideas here for us to consider today and for us to think about for a future for California that'll help increase our load flex and take us to our 7,000 gigawatt or 7,000 megawatt or beyond. So that's kind of where we are. Oh, too low? Is that better? It's very rare that anyone asks me to raise my voice. So this is interesting. All right, so this panel is an excellent panel to give us some ideas. They've worked internationally, nationally, and also in California, to give us some ideas about ways to make load flex better. We have with us Seth Frader Thompson from EnergyHub, Trevor McManamon from LEAP, Naoya Motegi from Honda, and Nick Chaset from Octopus Energy, as well as Brian Turner from Advanced Energy United. We're going to give each of them a few moments. Oops, I should advance this. Give each of them a few moments to give us an overview of some programs that they're aware of that they think could be valuable for California. And then we'll move to Q&A. I'll have a few questions, and then we'll be pulling up the questions from the audience. So make sure you continue populating these and upvoting them as we get through this process so that we can get the most out of this last session. So with that, I'll turn to Seth first, and I'll advance the slides for you here, Seth. Oh, maybe I can.
Do I need to? Okay, so I hold this down to talk.
There we go.
All right. Well, thank you, everyone who organized this for giving me a chance to talk about the other 49 states. Thank you to Commissioner McAllister for the invitation originally on this. You can go to the next slide. So just quickly, it would have been helpful if we'd put a map on here, but just to kind of talk about like why EnergyHub's opinion is relevant and what our bona fides are. I think we have more DERs on our platform than the rest of the industry combined. We run more than 100 DER programs for more than 80 utilities across North America. Almost 2 million DERs on the platform, about 2,400 megawatts of dispatchable flexible capacity. That's like, call it 10,000 plus megawatts of total load under management. So a lot of experience, and just generally we have broad experience building and scaling successful VPPs. Areas where we work, Duke Energy across multiple states, but especially in the Carolinas, Eversource, National Grid, many other states in the Northeast, APS, SRP in Arizona, LADWP in Southern California, Edison here. So lots of big utilities and lots of small utilities around the US. So what stands out about California, just to kind of give you the highlight of my opinion here, is California, I think, leads the US and in many ways leads the world in accelerating, driving the adoption of DERs, but really underperforms in leveraging those DERs for participating in grid services. That is kind of the takeaway, and I'll talk about sort of some data on that. So I think you can go to the next. Okay, so a few programs to highlight. So the IESO is an interesting entity in Ontario, Canada. Think of it as sort of like the CAISO Plus, or in some ways it has some similarities with Texas in that they have a common meter data repository database across the province. So there's 5 million homes in the province, so about a third the size of California. We launched just the Smart Thermostat program, no other DERs there yet. We launched that program. It hit 100,000 participants in just 6 months. It's already at 250,000 programs. It's still growing tens of thousands of customers per month. So this is an example of how programs can scale very quickly. And the analogy here is also that Ontario did a really good job of seeding the market and accelerating the adoption of smart thermostats. And then once they'd done that, so they sort of seeded the market, they tapped into them. The DERs are available for both system-wide flexibility and local distribution issues. They've implemented the program across both the ISO and all of the local distribution companies. There are more than 60 distribution poles and wire companies in Ontario, and everybody has access to the devices that are in their territory for sort of whatever needs that may exist. It's very easy for vendors to participate. And probably crucially, if you're in California and you're thinking about like data access, there are no data access problems here because the IESO does all of the settlement in M&V itself using that central meter database. So a DER vendor comes along, customers participate, you say, here's how the participation worked, and you have just very quick, rapid sort of estimation of performance. APS and SRP are adjoining utilities in the Phoenix area, about 2 million meters between the two of them. They have more than 200,000 customers participating just in their smart thermostat programs. They've already launched now battery and EV and CNI and other programs. So almost 10% of, actually now maybe more than 10% of customers in APS and SRP territory are actively participating with a DER in a grid flexibility program. So if you looked at the analogy, there's 10-ish million homes that might be an undercount for IOUs in California, but by extension, if California were performing at the same level, you should have at least 1 million DERs performing in California. That's not what we see. Going back to APS and SRP, it's a true direct load control. The system operators at the utility get to make a decision in a very flexible way. What are we going to do with the DERs? Do we flex them for market dynamics, for long-term system planning, for true emergencies, whatever the local distribution, whatever the need is. Another thing that's great about these programs is the simplicity. Everybody knows about these programs. You're hearing about them all the time in multiple channels. Arizona has even more extreme weather and climate than California, and yet they have this high participation. There's got to be a reason for that, and it's incredibly easy for customers to participate. So that's my take on sort of those two states or provinces. So I think with California, I mentioned you should have at least a million customers participating in IOU programs. You know, we're in the hundreds of thousands. This is just the IOU. If you had DSGS, it improves somewhat, but we're still off by probably 5x, even if you had per capita DER adoption on par with other markets. But you don't. It's California. You have more DERs here than anyone else. You're probably off by 10x. So there is so much room to do more. Next slide. And you can just build this out here. So the other program I want to point to is Connected Solutions. What I love about this program is kind of the sort of scale, simplicity, and diversity of it. But so kind of extrapolating from this and trying to wrap up, you focus on scale. If you're running flexibility programs, this is ultimately should be your main metric for whether your program design, your incentives, the sort of mechanisms of enrollment are working. If tons of customers are signing up, you've got it right. If not, you need to keep iterating. There is a single operator. I think the thing that California has made really difficult is it's not clear. Is this CAISO? Is it the utility? Is it the CCA? Is it market integrated? Is it direct load control? Is it an economic signal? So you need a single operator and a simple sort of clear way of operating these things. To the point about simplicity, you need a customer experience that is incredibly easy. Customers are signing up very broadly for flexibility, right? They're like, sure, I will do something for the grid. They're not thinking about like, is this system-wide capacity or is it local grid congestion? They're saying yes, and that should be the end of it. And then last, this is what utilities and system operators do in terms of like taking all this complexity behind the scenes and ultimately just making it so that you turn the lights on and the lights go on, right? We can apply that same basic kind of thought process to making flexibility work. Take all the brain damaging stuff necessary to make this work and do it behind the scenes so that customers don't have to think about it. And then the last thing is design based on the DER sort of inherent characteristics. Do your program design based on the fact that you can flex a thermostat only so many times before customers get annoyed that their house is hot. You can flex a battery, an EV all day, every day, as long as it's plugged in without customers noticing. You can design compensation schemes with those in mind. Just be thoughtful about it. I think that's it. Yeah, and we can come back to this. Thanks.
Thank you, Seth. We'll go ahead for time and move on to Trevor.
Hello, I am Trevor McManamon, the head of market development and regulatory with LEAP. LEAP is, we call ourselves an aggregator of aggregators, so I'm not sure if that makes us doubly problematic or doubly good for the grid, but we work with what we call our DER partners, and there's a few examples on the slide there. So across battery storage, electric vehicles, and smart buildings or smart devices, and we span both the residential and primarily small commercial and industrial space. We don't spend as much time with larger customers. And what we do is we connect those partners to grid services programs, whether that's a wholesale market, a utility program, or a state or other local program to support the grid and pass along most of the revenue to them so that they can share that along with their end customers. Go ahead and go to the next slide. Sorry, maybe skip 2 slides actually. So the 2 examples that I'm going to talk about today are Texas and Massachusetts, and at the highest level, they're going to be examples related to data, so going to encompass both data access as well as measurement and verification. So within Texas, you don't actually need to have access to the interval data, similar to Ontario, in order to actually participate in their Emergency Responsive Service, or ERS program. I took a look back at some of our historical participation numbers, and if you looked at our portfolios comparing Texas and California 3 years ago, we were about 100 times bigger in California. If you look 2 years ago, we were about 10 times bigger in California, and this year we're going to be pretty similar portfolio sizes between Texas and California. And I think a lot of that comes down to ease of authorization to enter the market for end customers. We do like having access to interval data. It's not required, and Texas does generally have a slightly better construct for that. So they have a single database that is run by the CPUC, the PUCT in Texas, and that is across all of the major utilities there. And one of the particular benefits that we like about that construct is, it's come up a couple times, but a single one-click gives authorization to the aggregator to access the data. So it's as seamless of a process as possible. Switching gears over to the Clean Peak Energy Standard within Massachusetts. There are a lot of DSGS-like aspects that you'll probably see on this slide that we are fans of. So the first one is being able to use device-level data. So that is whether it's batteries or electric vehicles or electric vehicle chargers or smart thermostat runtime data, all of those are eligible to be used for performance and settlement within the program. It also allows for exports, which has come up a couple of times today as well. Along those lines, baselines. We also are a fan of the flexibility and options that are available for baselines within the Clean Peak Energy Standard. So if you are a resource that is kind of more of an emergency type resource, not used super frequently, there's the kind of traditional 5 and 10 or 10 and 10 customer baseline load baseline that is available. If you are a resource that wants to be used on every single day, then you can use alternative baselines that are oftentimes static or prescriptive baselines that are a little bit more fixed that you can measure yourself against. The other aspect that we like is it is generally an independent third party, the Massachusetts Department of Energy Resources, and they kind of open it up for the whole marketplace to figure out the best way to solve their goal. And that goal is providing clean energy resources to meet the peak demand. As an energy geek, I'm kind of a fan of this approach. It was kind of an evolution of renewable portfolio standards, but really focused on the next challenge that needs to be solved. Go ahead and go to the next slide. So within California, Cliff on the last panel mentioned the challenges with Share My Data. We see pretty low conversion rates as well. The other aspect that has come up earlier on today is customer choice related to incentives. So the SGIP incentives for battery storage. those are not eligible for third-party RA contracts. So even if we're participating in supply-side demand resources, those customers are not able to collect S-chip incentives, and the same goes for automated DR. We think it's important for customers to have the ability to choose whichever program they think makes the most sense, and those are not eligible for participation. Similarly, DSGS option 4 that was recently approved, it's not open to customers within the PG&E territory. And while we understand some of the reasons for that and actually agree with some of them, I think in general customer choice is something that we are in favor of. Baselines, the baselines that are most commonly used, the CBL baselines, are appropriate for kind of traditional DR from 10 years ago that doesn't want to be interrupted very frequently. The DERs that are out there today, electric vehicles, battery storage, they are quite comfortable with participation on a daily basis. And these baselines actually disincentivize participation on a regular basis, which we want them to be used and useful as much as possible. And then lastly, device level data, we've touched on it a few times, but it is really a key pathway in order to be able to tap into both the battery that might be controlled by one entity, the smart thermostat that might be controlled by another entity, and the electric vehicle that might be controlled by the third entity. So being able to tap into and more precisely measure the performance from each of those devices is something that we would like to see going forward within California. Thanks.
All right, we'll move to Naoya. Oh, I'm sorry. Nope.
Hi, my name is Naoya Motegi from Honda Motor. I'm mainly working for energy service using the electric vehicle and mainly for US market. The first slide that I show you is what Honda is doing for energy system design. So for doing the vehicle grid integration technology into the market, we are doing the R&D for load control, dynamic pricing, and of course pay cut and the frequency balancing technology too, the control. And then, but this is the heart of the VGI technology, but this is not enough for us to do it. So we, addition to do it, we doing the battery system management technology too, R&D, because if the customer's number one anxiety is how much the battery capacity is reduced by doing this kind of the demand response participation. So we have to identify how much battery is going to be deteriorized, and then how much capacity is reduced, so that customer can participate to the demand response program without that much anxiety. And also we have to come up with the automated charging technology too. So without those automated capability, a customer has to have the very much hassle to every time to participate and charge and stop charging. So including all of them, it is very important to go deploy the vehicle to grid integration into the market. Next slide. So far, we have been doing this integration and the deployment for each area all over the world. So we have 3 areas. The first one is the EU and UK area. We launched a smart charging service, which is called eProgress in UK and EU area. And in United States, we established the OVGIP joint venture, which is the platform system which integrates the utility company and end users. And also we are working with the HEMS technology company, which is called Employer, to create the aggregated solution, to create the integrated solution with the home management too. And in Japan, we have been working with Mitsubishi Corporation to have the energy management business throughout the entire life cycle of the vehicle battery. So not only using the vehicle battery as a vehicle, but after that, after using that, battery at the car, we are using that for repurposed battery for grid scale battery as well. So and also we make sure that can be recycled in well manner. So integrating all those technology worldwide, then we're trying to come up with the best way to install and deploy this kind of technology into the market. Next slide. And here's the last slide. This is the example that we're starting doing. This is we are launching the EV Smart Charging pilot program in Japan, which is the optimizing charging schedule with the market-based dynamic pricing. So for this, we are working with the retail power company, which is provide the dynamic pricing rate. So that then one of the optimizing engine is trying to create the optimized schedule so that user's car can be scheduled to charge in appropriate time, considering the dynamic pricing rate changes. So including all those stuff, the point is that we need to come up with the not only for the VGI capability, but also to deploy all those energy services, we need to consider about all the other aspects, and we have to aggregate all the benefit, including the emergency backup, and also the home consumption of the excess PV generation, and all those stuff. So not only for the V1G, V2G capability, so because each of the benefit is quite small, so we have to sum up so that it's going to be good enough for the customers. And also we have to provide enough data so that user can participate and use their EV battery without that much anxiety. So that's the point. So we always have to provide enough data and come through with our customers so that customer wants to participate in this V1G, V2G participation. All right, that's it.
Thank you. We'll now move to Nick.
Hold it down. Yeah, great.
I'm gonna, while you're doing that, I'm gonna put up the Slido number again.
Okay.
Since we're done with slides, so we'll put this up so folks can ask questions.
So Octopus Energy may not be well known to folks here. We are a UK-based consumer and energy technology company. We're the largest supplier of electricity in the UK and the fastest growing supplier of electricity in Europe. We also have a retail electricity business in Texas, one in Japan and New Zealand. We're looking at this slightly differently from my colleagues here who are more sort of primarily utility service providers. We do sell software to utilities. But when we think about flexibility, I think the core mindset shift, and I formerly worked for the California Public Utilities Commission, formerly worked for a CCA, so I'm very aware of sort of the California framework. But the core mindset shift from my perspective, now working for retailers, we have to move away from thinking about flexibility, distributed energy management as a customer program that's always going to live in a customer program land with customer program budgets, that when those budgets are spent, you sort of stop doing things, to start treating it like a core strategy of your organization. As a retailer, we don't have a regulator that says you must spend this much money or that much money on flexibility. We view it as we view it as imperative. Some people don't. And that's why we have 50-60% of our customers, for instance, in the UK who drive EVs, allow us to dynamically manage the charging of their EV every day. Why do they do that? Because we offer them 70% off the cost of charging their EV if they let us manage the charging. For V2G customers, you charge for free if you let us or do charge and discharge of your vehicles. We roll these programs out. The things that work, we scale. The things that don't work, we pull back on. So, I think it's that core strategy piece. One of the challenges for many utilities in the US of treating it as a core strategy is they operate in sort of a core technology stack where implementing a new time of use rate is not something you will do one day to the next, 1 month to the next. It could take you a year. It could take you 2 years to implement fairly straightforward, somewhat complex rate changes. How can you dynamically engage with your customers with circumstances on the grid changing if you yourself can't change sort of the core measure of how people think about the cost of energy? That modern technology at the heart, the beating heart of a utility or a retailer is that system. If you don't have a system that allows you to do it, you're going to struggle to scale. So that's sort of an experience. I think the other sort of mindset shift that I think you get when you're a retailer and you're worried about customer acquisition, you're worried about churn, is people don't buy EVs. They don't buy solar and storage, or frankly a smart thermostat, to provide utility to the grid. You adopt these things because they have utility to you. It's going to make my house more comfortable. It's a better car to drive so I can get to work or take my kids to school. I have solar and storage for resiliency if the power is going to go out, or to help lower my bill. So we have to think about the experience for how you onboard, you acquire customers into flexibility programs, first and foremost as we're asking them to do something they may not want to do in the sort of the worst case, or at least they're indifferent to doing if it's an EV with managed charging. So we have to make the experiences really easy. We have to think about what is the cost to acquire those customers into these programs, and what is the likelihood that they're going to churn out if these programs give bad experiences. And then have the systems in place from a technology perspective to ensure that. And I think that's something that the folks at EnergyHub in particular have done a really good job of creating a ease of experience. But again, they run into the brick wall of the core billing system, the core technology is inflexible. You can only go so far. I think here in California, we absolutely have this massive opportunity. So many electric vehicles. Yeah, we have sort of an alphabet soup of different customer programs and different ways to access value. And what the result is, it's really hard to participate as a consumer. And so I challenge us in California to think like consumer companies. It's hard as a utility or a CCA when you are not necessarily competing every day to keep those customers. But I challenge us, if we're going to scale flexibility, we have to think like consumer companies. We have to think like retail electricity suppliers in a sense, even if we don't have that market framework. Otherwise, we're going to just continue to sort of nibble around the edges.
Thank you, Nick. Actually, Brian, do you want to use this one? Then they can share that one. I think this one should work.
Thank you. Thank you. Good afternoon, everybody. My name is Brian Turner. I am the Western Regulatory Director for Advanced Energy United. Advanced Energy United is an industry association across the clean energy spectrum, from large-scale renewable developers down to home solar and storage, to EVs and charging companies, and a lot of corporate customers that utilize these programs, want to buy clean energy, have solar panels and EV chargers in the parking lot. And we were asked to take about lessons from elsewhere for California, and I wanted to talk about 3 big subjects: data access, resource adequacy value, that is generation capacity value, and infrastructure value, the fastest growing source of cost increase on your rates right now, and what can load flexibility do for that. So first, on data access, we've actually, I'm cleanup batter here, so everybody's already said everything useful, but Texas, and California is being beat by Texas on data access, but other states also are catching up. New York and Illinois are also in the process of putting in platforms even more expansive than Texas. So Texas started off, when they did smart meters, with creating a smart meter centralized data platform where you can access that customer energy data use. You can talk to customers, show them how they're going to make savings with load flexibility, for instance. But then also it does some of the settlement for you. It does some of the quality control. It is and it is consistent across the state, so that if you are a multi-site entity, you don't have to access different data if you're in Southern California Edison and PG&E, et cetera. You've got one central platform for it. And as I say, New York and Illinois are implementing their own platforms goes one step further. It brings in the grid data. This is your hosting capacity analysis, your load capacity, interconnection capacity analysis type data. So you know where on the grid you can locate and what's the value of load flexibility, for instance, or export generation at any particular time, at any particular place. And that's really, really important. That's going to get us to that infrastructure value here in just a minute. So just the information of the grid data on a common platform is something that is being implemented elsewhere in the country, elsewhere in the world. The UK is a leader on this and would be a great benefit for California. RA value. Somebody already mentioned, I think it was Trevor, on the having a smaller grid operator. So we do a lot of work with the still vertically integrated utilities around the West, and they know their system well. They can see their system. They don't have to worry about, is this resource showing up on the grid? So you can talk about how California seems to be going with DERMS for the distribution system operator needing to integrate with the system operator as a whole. You can talk about visibility of at sub areas. So recreate that smaller system and think about how resources are shared on a smaller basis. And California is working on this. We've heard about the modified PDR approach, which looks at a smaller area and nets out exports in a smaller area. So that kind of recreates that smaller system in a way. And then device level telemetry and how we can have more assurance about the performance of resources through device level telemetry. It doesn't just have to be your batteries or your EVs. You can take thermostat runtime, as DGS option 4 does, and make an assumption about what that means for the performance, the energy saved. So that's on generation. And then lastly, on infrastructure value. And there were a couple of things here I wanted to hit. We see we see actually in a couple of the leading VPP examples in the country. I'll point to New York, for instance, which attaches a location-specific value to performance in certain areas. They know the value of deferring new infrastructure in that area. They provide it on a contractual basis for the VPPs. And I think that locational value on an ongoing basis assured to resources that show up in that area is really a future condition. California had a kind of experiment with bidding out how you were going to defer infrastructure in specific areas, and they would go out with a RFP for that. Well, what about if you calculated the value first and offered it to anybody who showed up? That's what they're doing in New York. I'm working on a case in Colorado. We'll be doing this for Denver. Well, there will be a value determined. If you are deferring infrastructure in this area, you'll have that value over at least the 5-year period. So those were the lessons I wanted to take, and I look forward to coming back to it in what California policy could be.
Great, thanks, Brian. So I'm going to start with some questions that I have, and then we'll go to the questions from the audience as well. So multiple people. First of all, I'll go back to what Seth had said, which is you got to do a lot of hard work on the back end to make it simple on the front end. And I think we all recognize this is a particular case where it is very complex, but you're working with customers. It's got to be easy for them. They're not going to participate if they don't, if it's difficult. So you, Trevor, Brian, all mentioned data access, different approaches to data access, kind of given the structure of IOUs, POUs, CCAs in California, what recommendations would you have about like transferring some of these ideas that you have from other locations to California relative to data access and also baselines and M&V? Start with you, Seth.
Yeah, so I mean, I think I cleared this with Trevor ahead of time to make sure he wasn't going to get mad. So EnergyHub is not an aggregator, but we sell a DERMS software platform, and one of the things it does is it lets utilities aggregate. I think LEAP is an aggregator, but kind of not in the way as the sort of traditional demand response aggregators. I would end the concept of sort of third-party aggregators and all of the baggage that comes with that, right? I think that like the DER manufacturers in general kind of are the aggregators these days. You know, if you're Tesla, you aggregate your batteries. If you're, you know, Ecobee, you aggregate your thermostats. If you're GM, you aggregate your cars. So I think once you do away with that, and you say, okay, so now we've got direct access to the device telemetry, like you mentioned, and then if you have an entity that is taking on the back end of taking the data, you can fuse that AMI data with the DER telemetry. You don't need to share it with anyone. Nobody wants that data in general to sort of demonstrate their performance. You can do that on the back end, and you can get phenomenally accurate, right? You have super long time series data for the performance of every individual DER, and you have super long time series data from the smart meter. You put those things together and you can get super accurate. We can solve this problem of how do you have multiple DERs operating behind the same meter. You can say, here's what the car did, here's what the battery did, here's what the HVAC system did. That is really not rocket science, and that would be where I would start today in terms of just sort of blowing up this whole concept of sort of a federated M&V approach and just centralize the whole thing, bring in all the data you've got, and do the analysis.
So at Leap, we think that wholesale markets are really important, and it's really important for DERs to be contributing to that space. It's where the grid scale planning happens. A couple of ideas that we have are the CEC has access to interval data across the country, and one of the ways that they've been using it is within DSGS option 3, creating a prescriptive baseline. Or we think that is an approach that would be helpful. So Massachusetts Clean Peak Standard has a similar construct, and basically what a prescriptive baseline is it looks at what is average load for a similar customer. So you look at all of the customers that have a battery installed at their home that's a similar size, look at what their typical load data is, and then if you have performance above and beyond what that load is, so a little slightly lower load that you curtail, you get credit for that performance. So we think the CEC, because they have access to all of this interval data, would be in a good position to be able to help create those prescriptive baselines that can be used in the wholesale market going forward.
Right?
But I'm hoping that Nick might chime into it because it talks about this core platform functionality and taking it out of the utilities. No knock on the utilities, but it just seems like there's a hell of a lot of savings and efficiency to be had by creating one platform that captures the whole state, and that to which additional functionality can be added or subtracted as it rises and falls in usefulness, and that. Yeah, maybe I see you getting ready to talk about that, but that's my idea for the data access that would make it more available.
So I'm actually going to totally agree with Seth here. I think we're talking about residential, so let's maybe commercial customers. It's a different thing. They want residential customers don't want access to their meter data. 95% do not want access to meter data. They don't actually want to think about their utility. They just want affordable bills. They want the lights to come on. So it's really an ease of use question. DERs should have no marginal cost because the difference of plugging my car in and it charging immediately or starting to charge at midnight or 1 o'clock in the morning, all I care, I want the outcome. Charged car in the morning. My solar system with a battery, what I want is maximal value against the time of use rate. So if it starts discharging at 4 p.m. or 6 p.m., I don't care. As long as I get that, I want 20% reserved for an outage, and I want you to revenue maximize. Thermostats are slightly different dynamic from a comfort perspective, but even there, if you just make it easy parameterization of I get some meaningful benefit, free thermostat, some discount on my energy, just let it happen in the background. If you have everything sort of controlled centrally by the load serving entity, you can just eliminate a lot of M&V, a lot of data access challenges, because it is complex. And if you're not going to go the whole way to sort of fundamentally re-platform your system, it becomes hard to create a centralized data platform, but I still have a spaghetti soup of internal technology that I have to integrate with a new data platform, and suddenly it's that much more difficult to effectuate.
The one other thing I forgot to mention baselines. You can do a lot with engineered baselines, right? We are being magically live whatever, transcribed here by AI, right? Do you think we can't tell you what your thermostat or battery would have done but for like a grid services event? It's fairly trivial at this point. Like we have been doing that at scale maturely for like, I don't know, 8 years since when the company was like 17 people and it was one company. Like this problem was solved a long time ago. So I think as I look at the data issues, the baselining issues, the attribution issues, every one of these issues is really not a technology issue. It's more of a spaghetti issue of like, what are you trying to untangle from legacy arrangements?
Great. Thank you for that overview. And now I want to go to V2X for a couple questions for Naoya and for Nick. Naoya, for your e-progress, one of the things that's intent on part of that program is kind of the balancing of renewables with the recharging. So I'd like to talk a little bit about that since that's obviously strong interest here in California. I think your experience in the UK might be a little different in terms of the balance, but I'd like you to talk about that. And Nick, the question from audience, but also from me is like that customer experience on the V2X, people being anxious, they bought this car, they're worried about their investment. What are the ways that you engage with them to make them comfortable and want to be participating?
So I'm gonna answer first. For the experience in the e-progress in UK, we had the multiple rate program, which is dynamic and the dual rate and the fixed rate, and then comparing to all those three rates, the dynamic rate are always the most economical, and it makes the most benefit for the customers. So so that can be the similar kind of effect for California market as well. And in general, market-based dynamic pricing is usually cheaper than the fixed rate because the utility company doesn't have to have the risk of the fixed rate, so that if the market changes, then if they have the fixed rate, then sometimes they have to risk about they have to pay more. So in the case that by reducing the risk premium, usually the dynamic pricing can be cheaper than the fixed rate. So in terms of the difference of the renewable portfolio, in UK, the wind turbine is much bigger than the California portfolio. I think in California, the solar generation is much bigger. So in a case that in UK, the nighttime rate tend to be lower than the daytime rate. So in a case that for the charging behavior, the nighttime could be easier to manage automatically in a optimized schedule. But it could be challenging in California to optimize the charging behavior because the most cheapest rate in cheapest time is the daytime. It could be daytime. So in a case that people wants to or optimized control wants to charge the car during the daytime, but at the time the car might not be at home or driving or at your work. So in a case that it could be the challenge to come up with the best economical solution, optimized schedule about that. And right now, we are starting the demonstration pilot program in Japan, which is similar to that's what I explained before. That is related to dynamic pricing in the market-based dynamic pricing. But in Japan, the solar ratio is bigger than the wind ratio. So probably that curve is not as much as the United States, not as much as California, but still having the same kind of like characteristics, solar characteristics. So the experience from Japan could be very beneficial for California's dynamic pricing deployment.
Thank you.
So with V2X, and really this could be sort of extended sort of all direct load controller control. It's really, trust is really important because you got again, you got to acquire the customer. They have to agree. Yes, you can control. Usually there's an economic incentive, but if they fundamentally don't have trust, they're not going to give you control over devices that have an impact on their lives. And so one of the things we have done, spend an exceedingly large amount of time and effort on, is building customer trust. That customer trust then gives customers confidence that when I give Octopus control over the charging of my car, I know that when I wake up in the morning, it's going to deliver the outcome that I expected. It's even more imperative with two-way discharge where there can be degradation. And part of that trust is just doing right by customers. We had an experience recently where there was an issue with actually a thermostat potentially sort of driving an unwanted customer outcome, and we just did right by the customer. They had to get the air conditioner repaired. We just gave them a bill credit equal to the cost of repair. That creates trust. When you trust, you're going to give that much more sort of buy-in to sort of what they're going to say, then they participate in your programs or in your rates.
Thanks. And as it relates to that comment, and this could be for anyone, audience question is really around the trust that comes with data privacy and security, and your experiences with that and building that with your customers.
A quick take on that is that I think again, you can sort of design things to minimize sort of the problem surface area. I think for the most part, if you eliminate the need to share data, share energy data, you solve one big problem. I don't know if do we still make white pages in this country? We used to make a book that had everybody's name and address. Like, a lot of this stuff literally comes down to saying, like, hi, my name is Seth, I live at this address, and I have this vehicle that's participating in this utility offering. And I think like the sensitivity of that is low, and I think if we design a good customer experience, most of the time that good customer experience will both be high performing in terms of the funnel conversion metrics and high performing in terms of privacy.
I'll just say, I think one challenge you have in security is when you have many, many different actors, you have many different points of failure. So in a home where you have, say, a thermostat aggregator, someone who's a different aggregator for I guess in California you can have multiple aggregators, but potentially like you'll have an app and someone who's controlling your EV different than you have an aggregator for your thermostat, a different aggregator, and then the utility has 5 different systems. Well, that's 8 different potential points of data breach and failure. Moving to a single platform, it's one door. That door has to be a really strong door, but like you really focus your energy on that door because that's the only place in and out. I think that's sort of part of our experience with Kraken.
2 bits that I would add. One on the authorization side of things, obviously very, very important for customers to actually authorize the data. I think there was some examples in the middle of the country of utilities where you could just ping an account number and get some utility data. We don't think that's a good construct. We think it's important to make sure that each end customer does actually authorize it. On the security side of things, I am not an expert in this area, but I know that our product and engineering team works through a process that is there's a standard process called SOC 2, and that's typically what a lot of utilities will require for us to actually be able to access the data. So there are certain protections at least in place and standards that we will meet as an aggregator.
All right, one slightly controversial question that keeps coming up is related to your experience with utilities and utilities being more invested, more interested in demand flex than maybe they currently have. So your thoughts on utility buy-in with demand flex and how to, if you've had challenges with that, how to overcome that.
I mean, I certainly am pro-utility. I think, I started EnergyHub a long time ago under a very different sort of initial theory of what the business was going to be, and the idea was that it was going to be mostly a direct-to-consumer business, and we were pleasantly surprised to find that for the most part, most of the progress and most of the speed is happening with the utilities, and in some ways, the more vertically integrated the utility, the faster they move. Not always true, but I have generally found that that's true. I agree with what Nick said, that like the concept of the customer program being like an other thing is probably not, that's not right. I think that what I see is the most advanced utilities in the US are thinking about flexibility being kind of a core part of the operating stack. Where that becomes, I think, particularly interesting is, so it's pretty common with demand response to have, you know, a 20-plus-year-old kind of core business model around, I have a capacity price that I'm trying to avoid, I have a transmission charge I'm trying to avoid, I have an avoided cost, whatever it is. But there's a business model that is well proven. What they're trying to do now is layer on other things, layer on ancillary services, layer on distribution value, more value to the end customer. And you start to see that then you start to integrate the systems, right? You take whatever piece of future software is going to be watching every piece of the distribution network to make sure that you can wring every last megawatt of capacity before you upgrade the distribution network. The long and short of it is that I have not seen in the US or anywhere else a mechanism by which all of those values can be stacked by any one entity other than a utility. And so, for example, like in Texas, there's really no way for the transmission distribution utilities to get a grid congestion kind of somehow bubbled up into the retail rate the end customer pays. You can do overlays of multiple programs, but then you get into this sort of thing that we talked about at the beginning of, you got to keep it simple. I've seen Australia, Northern Europe. It's possible they're doing this differently in Asia, but I'm not aware of it. What I keep seeing over and over again is that if you're going to have one entity, the utility is kind of the only entity that has access to all those value streams.
So it may not be a perfect construct, but I do think within New York, to Seth's point, it is layering many different streams or programs on top of each other. But that is something that we do today, is tap into the distribution value that utilities are offering for deferring some of their upgrades, tapping into the wholesale market, capacity, energy, et cetera. So I do think there are systems that work within that. More broadly, we definitely think that utilities need to be involved within distribution value. Obviously, they're the ones that have the lines, they own the lines, they see where the needs are, and they're the ones in charge of the upgrade. So there's absolutely a role for utilities there, but I think we're a little bit more skeptical whether utilities are going to be the quickest to innovate and move forward with as quickly as we need for this energy transition, and also not sure that sort of the incentive structures that is set up for utilities is incentivizing them to move as quickly as they should.
I think I've worked with a lot of California utilities. We at Octopus are working with a fair number of utilities across the U.S., certainly in Europe and Asia as well. I think fairly consistently, utilities want to do more, but they're constrained often by a regulatory framework. So in California, like, if you're a utility, you just feel like if anything I want to do, I want to offer a new rate, a new program, I have to go to my commission. It's going to take 18 to 24 months to get approval to roll it out. By the time I'm rolling this thing out, it's probably obsolete because the thing that I was trying to solve for, I have a new problem I need to solve for. So how do we create a regulatory framework for more sort of fast failing and iteration, and giving the utilities a little bit more ability to try things and not feel like, well, if I try it and I didn't hit some sort of esoteric cost effectiveness measure, they're going to deny cost recovery and I'm going to get penalized for it. So yeah, utilities are not perfect. I would say in Texas, the energy price does a heck of a lot to reflect those values. So yes, you can't necessarily monetize everything, but gosh, when you're facing up to $5,000 a megawatt hour, that captures a lot, and that is a pretty strong incentive to get load under control. And that's the name of the game. Once you have the load under control, if there's more economic value to solve for a distribution constraint than an energy market constraint, go to the load serving entity and you bilaterally negotiate, kind of sort of a direct load control there. The hard part is the acquisition, I would say, and I think by and large especially in the US with our model, the utilities are the most efficient acquisition channel.
For the utilities, usually right now we are, as a vehicle homeowner, we are participating in the demand response program through the aggregator or some other entities. So utilities sometimes provide the program and then they can participate, but in some cases not. So of course, the aggregation is very important right now. So there should be some way to participate in the aggregation through the aggregation. But in future, eventually, the customer users should have the option and selection to either directly connect to the utility or market, or to be aggregated by aggregator. So in the case that I want the utility to provide the open API or some way of connecting directly, so that we can do at some point, some customer can directly connect without any interfaces. So and also if customer has to provide their own data to utility companies, then for the discussion about the data access, we want, or customer wants to have the certain reason that or outcome of the how the data can be used and what's going to be the potential benefit out of the data collection by the utility companies. So in a case that if they know, then it's going to be good for society, or it's going to reduce the installation cost or like a maintenance cost of the grid, then some of them are welcome to participate and provide the data. So in a case those increasing information and informing the use of the data would be the very important thing. And also just to provide the data, of course, making API, maintaining API, and storing the data, it's gonna be of course, the increasing cost for OEMs too. So somehow we want some sort of the outcome or benefit doing compensation out of doing that.
To have a brief principles-based answer to it, which is that one of the core duties of regulation of public utilities is to correct for the negative impacts of monopoly. I don't think we should be making any decision one way or the other about whether the future belongs to the utilities or belongs to third parties, but allowing for those to flourish that can.
Okay, we'll do one last question as a lightning round to wrap things up. So, and we'll go in reverse order. So from Brian, from you on down this way, which is, if you had total control of DR or load flex in California, what's the first thing you do?
Round, if I have to think about it for, what is it?
You've thought about this for many, many years. You gotta have
Yes.
some good ideas.
Yes, is it RA value? Is it recognizing the infrastructure value? Or is it data access? It could be any of those three. That's my great answer.
Okay. Naoya?
So your question is from utility point of view or market point of view?
You had total control.
As a point of view of customer's point of view or anything?
From your point of view.
My point of view is a very tough question. I would say.
Other than having everyone drive a Honda.
I mean, like from my point of view, if we can control everything without any much hassle, and ideally, of course the in a light timing, in a light equipment should be controlled in most efficient manner. So in the case that the end user equipment some of the end user equipment are installed with not for the grid participation, but they have their own role to do it. So, but if that is not used at the time, then they can use for demand shift or demand curtailment. So in a case that at some point, at some time, or at some amount, or at some speed, that some of the end-use equipment are not really used, including the car. So in the case that ideally, the most effective, most economic, reliable solution should come in the beginning, and then eventually we can plan the portfolio of the entire grid of those resources, and then we not gonna invest too much adjusting resources without using the existing end-use equipment resources. So, that can be my answer? Is that okay?
Thanks. Nick?
I would require all solar and storage systems participating in net energy metering to enroll with a DERMS for control, and I would make any EV buyer who wants to take a state incentive towards the purchase of their EV enroll that vehicle in some sort of basic managed charging.
Trevor?
I would tweak the data authorization process to allow in-app authorization. So if you have an Ecobee app, instead of having to go to the utility website and enter in your login credentials, just being able to click at one point during that process. I think the conversion enrollment rates of people that have indicated they want to participate in a program that don't actually end up making it all the way through is too big of a loss for the state.
Seth?
I think this is the single most exciting question I've ever gotten on stage. Plus one to what Nick said. I think that we do need we need to just maximize the participation of DERs in the grid in general, and I think you could connect that all the way from kind of the interconnection process to the incentives all the way down. So, but back to the core question, I think that if I were king of California for a day, I would either do a single platform, so think a multi-tenant platform where you have one platform that is responsible for orchestrating all demand flexibility across the state and is sort of has multiple overlapping but limited access to, so that the wires utilities would have access to what's in their territory, the system operator would have access to everything in their territory, et cetera. That would be the perfect model. Failing that, I would go with something that just cleans up. You have a central system, call it for the statewide, the CAISO, and then dramatically cleans up the way the utility systems plug into that and clarify that the sort of all of the mechanics of how those systems work together. And in both cases, I would say use off-the-shelf software that is heavily proven outside of California.
Wonderful. Well, a round of applause for our great panel. And indeed, you gave us good ideas to think about in California, as I predicted we would. So I think at this point, I'm going to turn it back over to, is it you, Ben, or to you, Vice Chair? Vice Chair.